computer. There we go. I think I'm recording. Do you guys see the little recording thing? Yes, I'm recording. Okay, cool. Couple of things. I mean, first of all, if you go to this main page and you go to the course syllabus, okay, what's going to happen is after every class that I teach, I will be making the week a link. So for example, after the class last time, I made this a link, and you can see this is where all the software that I was talking about that you can download for, Max MSP or something like this. At the top of this, I will put the recording, the link to the recording for that class. So if you want to go back and relive the glories of last week's class, you can go and click on this, and you'll hear it. Okay. So that's where everything's going to be, John. All right. Now, Zoom has to process these recordings, and it takes a while for that to happen sometimes. And I'll also be putting on these class links all of the patches and scripts and things like that I do in class. So you'll have access to everything there. Owner had an idea that we're investigating of actually using like a shared code editor. Let me know if you think that would be a good or a bad idea. Basically, this is something where it's kind of like Google Docs, where I can put up something that I'm editing, and then you can actually see it all and like click and download it and do whatever you need to do. Otherwise, I'm just going to kind of do it like this, and you'll see what I'm doing. Today, it's not going to make a big difference because we're not going to be doing that dense coding. But yeah, maybe in the future at some point it might. Speaking of the future, I have some other good news, okay? We have now, Doug Scott is going to be coming to talk next week. Ideally, he would have been the following week, but he had a conflict then. So I think I'm going to go ahead and sandwich him in there. And he's one of the co-developers of RTCMix with me, and he's done a lot of the work on it. So he'll be talking about his own music, talking about the way he uses RTCMix, some of the features that he likes, and things like that, okay? Laura, who's actually here with us right now, will be talking at the end of October about her work, because that's when we're going to be starting to move into more web-based stuff and using this in the context of the internet, which is some of the cool news. I have some other kind of special guest stars that are going to be showing up that I've been talking to. There's a guy named Ross from Yale who's been doing some interesting stuff. And my former student and good friend Damon Holtzborn has been working, we'll be doing this here probably, has been working with this. I mentioned this thing that Miller Puckett has been doing in PD, where you get very fast latency, peer-to-peer. I'm not quite sure how he's doing it, but we're going to learn how he's doing it because Miller actually offered to come and talk to the class too. So yeah, we got some pretty cool people showing up. You don't have to listen to me the whole time. Alrighty. Now, what I want to do today is cover the basics of RTCMix and just kind of introduce you to kind of some of the ideas of algorithmic composition and how they work. And along the way, I'm going to be showing some of the features of the RTCMix language, okay? So let me go here. Shoot, I can't do that. Let me hide this away. All right. Let me start at Max MSP. And the thing to realize, even though I'm showing Max MSP, RTCMix is a completely different language that's embedded inside Max MSP, or it's embedded inside PD. Or you can run it in that RTCMix shell, or you can run it as a standalone on a Linux platform, or a Mac OS X platform, something like that. The reason I'm going to suggest using it in PD or Max MSP is because it's embedded in those languages. And the work that we do when we get to network stuff, it will be embedded inside a network application. What that means is that we have external sources of control that you don't have access to if you're running it standalone. Okay, so I think it's going to be, like I said, you'll see some of that today. We're going to do some interesting, one little thing with a slider that's kind of fun. Okay, so like I said, my essential max patch looks like this. Okay, RTCMix tilde, bang. You know what? I'm going to make this bigger too. Zoom it up a little bit to maybe 150% so you can see a bit more. Okay, is that better for you guys? Does it matter? Yeah, I'm hoping that it's okay. Okay, EZDAC. Okay, so this has the audio output from the RTC mix process. This has some other data coming out of it, okay? And I want to point out that RTC mix tilde on its own is a mono instrument, okay? The bang just triggers what we're going to be doing in RTC mix. You can specify that you want 2 channels out. And notice that another thing opened up here. That would be my second channel that I could attach down there. You can actually do any number of channels coming out of the RTC mix tilde if you want. Okay, and there's a third optional parameter that we'll talk about at some point in the future. It's for controlling individual note kind of evolution. But for now, I'm just going to do something in mono, okay? And let me save this now. Okay. Now, here's the cool thing. See, I have all these things already pre-made. So in case I really screw up, I can arg. You guys don't see what's happening. Zoom is just one of the most annoying programs in the entire world, as far as I'm concerned. Oh, good, I can move it down there. What was happening is that the upper like menu part of the window was being hidden by the Zoom stuff, so I couldn't get to it and like do the save and everything like that. So, oh, let me hold on a minute. So let me try that again. Okay, we're going to say save as. Okay, yeah, now we're going to call this, we'll call this RTC Mix 1 just for fun. Okay, they may be called something different when I get them on the thing. Okay, now, to get access to the RTC Mix language, you close the patch, you lock it, and then you double click on the object. That's true in PD also, okay? And this script here, script 0, this is the RTC Mix language. It's a text-based language. We're going to be doing text-based stuff. It's powered by instruments. I'm going to be showing you the documentation in a minute. And you use the instruments to schedule notes. So it's a scheduled language. This is what makes it kind of fun. And it makes it a little different from a lot of the other languages that are out there. Its sense of concurrency is built into just it runs. When you schedule something, you can say, I want this note to appear 3 minutes from now. I want this note to appear a half a second from now. I want this note to appear as soon as I trigger the script. You know, all these times you can schedule, you can schedule something, 10,000 minutes in the future if you want, okay? Yeah, I got something, I'm waiting for it. Anyhow, but the way it works is that you have these instruments that you call like functions. And I'm going to show you the documentation now. I'm going to put this link in. It's in the main page, but I'm going to put the link in on our class page too. So if you go to instruments, these are all the different instruments that we have in RTC Mix that can make different kinds of sounds. And the one I'm going to use initially is this one called Strum2. Okay, now this class, we're not going to be talking about synthesis per se, and I'm not going to really go into like how these things actually work. I'm going to be showing you some of these different instruments just so you get a sense of what they can do. Strum2 is a physical model based on the Karplus-Strong algorithm. And I'm just going to copy over this quick syntax. This is where you read about what the different parameters are. And we call them P fields because traditionally back in the 1980s, we labeled this P0, P1, P2, P3, P4. And this tells you what they do. We're not going to read that now because I'm just going to tell you what they do, okay? So first of all, I'm going to put this up here like so. And notice that I put these 2 things in front of it. That means that's a comment. RTC Mix will not see that when I run it. That's just for me to have like a mnemonic so that I can, yeah, I love that word, so that I can see what I'm doing. What I'm going to do is fill out these parameters. Now, they may not make a lot of sense to you right now, but I'll explain them. Outskip. Like I said, it's a scheduled language. This is how far do I go before I hear this note. Well, I want to hear it right away, so I'm going to go 0 seconds. Okay. What's the duration of the note? Well, let's make it be maybe 3.4 seconds. Okay. What's the amplitude? Now, this is a little tricky because this shows it's kind of like computer music heritage. The amplitude scale is 0 to 32,768. Well, why is that so weird? That's because 32,768 is 2 to the 16th. These are 16-bit samples, okay? If you work with 24-bit samples, you can go to a higher number. But we're doing 16-bit, so we're just going to use this. And I'm going to say that this is going to be at an amplitude of 20,000. Now, at some point, we probably should have changed this to a scale between 0 and 1, but we never did because we're lazy. So, sorry, you have to deal with it now, okay? Pitch, all right, let's just choose a pitch. Let's say 378.92 hertz. That's the fun thing about this, is that you can choose arbitrarily precise sort of notes. I'm going to be talking about another notation system in a second. Now, this thing, squish, if you read the documentation, this is a parameter specific to this physical model. This determines how sharp the attack is. It's a model of a plucked string, and the squish value is between 0 and 10. 0 is if you're picking it with a metal pick. 10 is if you're picking it with a really fat thumb. So it kind of goes flah, flah, flah. I'm just going to use 1 because that's not a bad sound. And the decay time, I'm just going to make that be my duration, but you can use something different. I also want you to notice that there's stuff in these weird square brackets. Those are optional parameters. I'm going to be talking about this one, pan, in a little bit. But for now, we're not. So I'm just going to say 3.4 for that. Okay, I've just created a fully functional RT-CMIX score or script. All right, to hear it, I have to close it, and I'm going to save it now just to be sure. Turn this on, and if I play this, did you hear it? Okay. Yes, I'm a computer musician. Yay! Oh, this is so much fun. You know, one of the things that's weird about Zoom is I can only see like 3 or 4 of you guys in my kind of display here. So I have no idea if my jokes are just really not going over at all. So let's see, just pretend like you're smiling or something, okay? Anyhow, so that's basically what an RT-CMIX script looks like. Now, here's the fun part, okay? Yeah, I can, like I said, I can change the outskip. Let's make it be, say, 2.5, oops, not 22.5, 2.58923 seconds from now. Now, when I hit the click, you're going to wait for 2.5398 seconds. 1001, 1002, 1005. It didn't work. Why not? Oh, because it's strum too. Computers are very stupid. You have to be very precise in what you tell them. If you call this instrument the wrong name, it will have done another instrument which had a different set of parameters, and it didn't make any sound. But this one, now it'll work. It'll be great. All right, ready? 1001, 1002, 1000.39. There we go. Do it again. Here it comes, here it comes. Ah, yay! So now you can amaze your friends and family by, you know, making notes appear as if by magic, okay? We'll go back to 0. Now, the other fun thing that you can do with this is that any of these numerical values that you see, you can replace with a name, a variable name, okay? I see Nicola there, okay? So we'll just say this one is called Nicola equals 0. Now, here we can say Nicola, and now it'll work. Sorry, I couldn't resist. A lot of times I'd say Fred for Fred Laerdal, but now Fred's no longer on our faculty, so I have to use students instead. No, I won't do that. I'll say start, okay, because that'll be our starting time, okay? All right, why is that important? Well, I'm going to show you in a second. But again, the takeaway is that this is a programming language, so we can actually assign variables and then use the values of the variables in what we're doing here, okay? That means that we can modify the values of the variables. Now here I am, and I'm clicking this. Oh, it's so much fun. It's a very minimal piece and I like it, but I'm a very, very lazy musician. And I don't like to click the mouse button. I want it to do it for me automatically. Here's what I can do. And this is what I showed you last week, just briefly, okay? I'll say something like this. While start is less than 4.4, plus 0.5. Okay. This is one of the essential things that you do in algorithmic composition. It's called a loop. And this is called a while loop, okay? And frankly, the while loop isn't used as much as another one I'm going to show you. What this is going to do is it's going to start out with start equal to 0. Now, initially, that's less than 4.4. So that means you do all the stuff that's within the curly braces. By the way, I should mention, I'm starting out really, really ridiculously slowly here. If this is really painful for you guys, I'm hoping it'll pick up as this kind of class unfolds a little bit. Or if I start getting way too complicated, again, please interrupt. Say, Brad, go, or Brad, we have no idea what you're saying, so kind of, keep me on my toes here. But basically, what you're doing is that this is a key thing. You can take a variable and reassign it, but use its original value. It will look at everything on the right hand of the equal sign before it assigns the left. So it'll say, oh, start equals 0. So I'm going to add 0.5 to it. Now it's 0.5. So it comes back around. This is now 0.5. Schedules the note. Then it goes, oh, start at 0.5. We're adding 0.5. Now it'll be 1. So it comes back around. Now it's 1. Schedules the note. So as long as this is less than 4.4, it's going to unroll this loop and schedule all those notes. So let me call this now RTC mix 2. And I only have to click it once. Wonderful. I am an algorithmic composer par excellence. Okay. Now, you don't have to do it that way. Okay. You can also have it be triggered externally. Like I could have used Max MSP has an object called Metro. We're going to show this object later on. But Metro generates bangs. And instead of having the loop in RTC mix, I could have kept it as a single note and then just have this bang it. But at some point, I'm still having the computer do the work. And the computer is the thing that's actually, scheduling the stuff. I'm going to, as much as possible, I'm going to try and keep everything within RTC mix, because that's going to be important when we do port it into another environment, like on the web or in Unity or something like that. Okay. Now, this loop called a while loop is okay, but the one that's more commonly used is called a for loop, and it looks like this. All right. Same thing pretty much, only the for loop has 3 different parts. Okay. The while loop only had 1, and we had to set up some stuff outside. Okay. This is the initialization. When it comes into the loop, that's the first thing it does, is it sets this variable called I to 0. And as long as it's 7, it adds 1 to I. So this will basically generate 7 notes for me, okay? And it's very important. Now, at this point, I want to point out a few things about what we've been doing. If you're a programmer, you're noticing that there's some odd things about this. First of all, we're freely mixing numbers with decimal points and numbers without, okay? It's integers or what we call floating point numbers. That's because the parser allows us to do this. Underlying RTC mix is all converted into double precision, if that makes a difference for you. And we're also very careful that we don't get that weird round off error that sometimes occurs when you do that conversion, all right? The other thing is that most programming languages in the world will have semicolons. at the end of their statements. I hate semicolons at the end of statements. I've spent years of my life trying to debug code because I forgot to type a semicolon at the end of my statement. So I thought, hey, I'm going to design this. I'll do it the way I want to. And it turns out there's a way that you can actually get it to be sort of interestingly context-free, and you don't have to type in the semicolons. You do in the for statement, because you have to separate those guys so the for thing knows that this is the initialization, this is the condition to terminate, and that's the counter. Okay, but other than that, no semicolons. All righty. Let me see, where do we want to go from here? All right, now we're going to start thinking about like actual algorithmic composition, and I'm going to hit kind of two main types. There's what we call deterministic algorithmic composition, which is you're just using math, okay, and you're going to know what's going to happen. It's just a way of being able to kind of really do things quickly and elegantly, you know, that you could do just by like typing the stuff in if you wanted to. And then we're going to look at probabilistic approaches, and that's where it gets a bit more interesting, because that's when we can start fooling with you know, chance procedures, decisions, and things like that. But first of all, let's do a deterministic thing, okay? And for this, I'm going to introduce you to another RTC mix instrument. This one is a real workhorse, okay? It's called wavetable, all right? And what wavetable is it's an oscillator, okay? It's called a wavetable because the thing it oscillates is we actually construct a thing called a table inside computer memory, and I'm going to talk about that later, okay? But let's get rid of our strum2 here, and let's put up wavetable with the parameters that we're going to fill in, okay? And same thing, outsk. By the way, if you're wondering what that stands for output skip. Same thing as start. It's how far do you skip on your output before you actually make the note. So we're going to make that be start. Dur, let's make the duration, let's be, let's see, what did I put down here? Let's say 0.5, okay? And let's make the amplitude be 20,000. Okay, and the pitch, we'll make the pitch be, let's originally just make sure we're getting some sound. So we'll make this be 500, okay? And these optional parameters we're not going to use yet, okay? All right, so by itself, with just those things, the default waveform that it will play is a sine wave, okay? So I should hear, let's make this be a little shorter. Let's make it be 0.2. I should hear 7 sine wave notes at 500 hertz, okay? Call this now RTC mix 3. Okay, here we go. There we go, okay? Wonderful, absolutely wonderful, all right? Now, here's what we're gonna do. We're gonna go in and we're gonna parameterize this a little bit, okay? First of all, I'm gonna make dur be 0.2, replace that with a variable, okay? Amp, I'm gonna say amp equals 20,000. Replace this with amp. And we're gonna say here, frequency equals 500, right there. Oh no, actually, let's say it out here first, okay? By the way, these spaces and the ordering of stuff doesn't really matter. You know, I can put things in any order that I want, okay? So we're gonna say frequency out here. Now, I'm gonna make some modifications to this, okay? We're gonna now call this RTC mix 4. Okay. I'm going to add something here that's going to be a little bit weird looking at first, okay? Notice that when I played that, it just like stopped and started the notes, and there were even clicks, you know, it's like stop, tap, 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 tap. I want a nice, elegant kind of, you know, fade in and fade out. Here's how we do that. We create a variable called amp end for amp envelope. we're going to use this RTC mix thing called make table. All right. What the heck is this? All right. Well, I won't show you in the documentation, but if you look it up, make table, when I talked about a waveform being a table, same thing as an array, sometimes it's called a buffer. It's a segment of computer memory where we construct something that we're going to access. What we're going to construct here is done using the parameter line for make table. And the 1,000 means that we're going to construct 1,000 different locations for this line. This is the specification for the line. It's time, value, time, value. So at time 0 in this line, or at the very beginning of it, be it a value of 0. At time 0.1, or halfway through our duration, be it a value of 1. At time 0.2, be a value of 0. What this will do is fill out that memory with numbers starting at 0, going up to 1, then going back down to 0 again, which will give me a nice fade up and fade down if I take that and I multiply it by the amplitude envelope. Okay, so this then, by the multiplication, this goes from 0 to 1, back down to 0 again. When it gets multiplied here, it'll go from 0 to 20,000, back down to 0 again. So I'll get a nice kind of sort of shape to it, okay? Let's hear it just for fun, okay? So now you can hear. And you're also hearing this weird kind of ringiness to it. It's kind of going, you know, and it's not a pure sine wave. We have to do one more thing. We have to say reset 44100. The default is that RCC mix only updates these pieces of control information only 1,000 times a second. This means it will update it every sample because we're operating at a sampling rate of 44,100. So now when I play it, you should hear a smoother sound. Right. Just something to keep in mind. Like I said, I'm trying to show you some of the features that you're going to need for this RTC mix language, okay? Now, as much fun as that is, you know, it's still pretty boring in terms of, you know, what it's actually doing. Well, let's do something a little bit more fun, okay? Let's start with our frequency of 500. And now here's the deterministic algorithm. We're going to say freq equals freq plus 20. Okay? So that means every time it loops, it's going to add 20 hertz to the frequency. And now we get this. Okay? Whoa, that sounds pretty fun and algorithmic, doesn't it? Okay? Yeah, but it doesn't really, I mean, that's not great, but this is what's fun to do, all right? Let's do that, but let's, instead of adding a half a second to our starting value, let's add 1/100th of a second. And let's make our duration be only 0.02, okay? Now, let's also give it 100 notes. I'll call this RTC mix 5. Now, was that too loud? Okay, good, all right. All of a sudden, we're starting to get something interesting. You know, it's not just the same old thing. In fact, let's start with it down here, 200 hertz. Let's add, let's do it for like 1,000 notes. No, let's do 10,000 notes, okay? All right, let's see what this sounds like. Listen. It's still going. It's still going. Aha! Why did it come back down? I wanted to do that, okay? This is a really weird phenomenon. It's called fold over. Basically, what happened was the frequency value that we were specifying went above the Nyquist frequency. The Nyquist frequency is half the sampling rate. And the Nyquist frequency, if you want to look it up, is the highest frequency that you can represent for a given sampling rate. Once we went above it, the poor computer says, I don't know what you're talking about. And it tried to interpret the numbers as best it could. And the way that it does that is it then creates a descending sort of set of frequencies that go down to 0. And then it would actually go back up again. So, if we took this and let's add, maybe 200 hertz, so it'll happen faster. And let's add 1,000th of a second to each one of these, okay? And let's keep it at that so we can hear kind of fun stuff, okay? Now you'll hear this. That kind of went berserk, didn't it? I'll be honest, I wasn't quite expecting that myself. But hey, that's what happens when you add 1,000th of a note and you add 10,000 of those thousandths of a second of notes. Anyhow, now I want to point out something else that's happened too. Notice my original make table, I said it had a duration of 0.2, and now my duration is 0.02, but it's still doing that fading up and fading down. If you could listen very closely to it, that's because it will always stretch this line specification to fit the duration of the note. So I didn't have to go back in and retype the whole specification for it. That's just like a convenience feature that we threw in, okay? So you'll see me, a lot of times I will just do something like this, 0, 0, 1, 1, 2, 0. That will give me a fade up and fade down, and it'll stretch to fit whatever note that I'm doing, okay? All right. So,
Brad, I think there are a couple of questions.
Okay, sure.
In the chat here.
In the chat, how do I see the chat? How do I see the chat? Hold on. Owner, I'm not seeing the chat. Maybe you could.
That's fine. I mean, Anthony says you answered his question.
Oh, I did. Okay. All right.
Justin says same frequency sounds flatter on my system. Does it have to do with the sample rate?
Yes. Okay. Yeah. This is something I've been kind of fooling around with. This is annoying. I remember I said Zoom was a very annoying program. Zoom actually works at a sampling rate of 48K. Not 44.1K. That's more common in the Windows world. It's more common with people who are doing video work. There's a way I can do the conversion, and I figured it out. In the future, when I need the sampling rate to be exactly 44.1, I will use this method. But right now, even though I'm saying this is 44.1, it's actually playing back at 48. So you're getting, it's a little bit less than a whole tone difference, I think. Okay. Yeah, sorry about that. I should have mentioned that earlier. Hey,
there's one more thing I forgot to ask you. Like, I remember doing something a couple of weeks ago to enable stereo sound on Zoom, but I think it's only for like the meetings I would host myself.
Yeah.
Did everybody like hear the sound like in stereo? Was that a problem for anybody?
We checked it earlier, right? And you got the left channel and the right channel? Yeah. I'm just playing mono now. So yeah, you're not hearing anything in stereo yet. Okay.
Yeah. Well, also, like if anybody's using like a Bluetooth headphone or something, it may just like sound like it's mono, but check if the microphone is also in use, because sometimes if the microphone is also in use, they switch to like mono for some reason. So
yeah.
All right.
Okay. All righty. Okie doke. Now, I want to work on another algorithm. How are we doing on time? Not too bad. Not too bad. I may not type this in. Like I said, I've pre-made some of these, and I kind of want to maybe just show you. But I want to talk about what I'm going to do. Okay. This is going to lead towards something that I want to finish the class with. But essentially, I wanted to capture the feeling of, I'm here on this island, and all we do for fun is go down and look at the waves on the shore. I want to do something that captured the feeling of a wave, kind of like going like that. Okay, so it's kind of like, kind of like that, okay? This is actually a part of algorithmic composition that you can do where you try to model natural processes. And we're going to be doing a lot more of that the week after Doug, you know, when we start getting to. By the way, this deterministic stuff seems kind of goofy now. Wait until we get to like some of the chaotic equations and things like that. It's pretty astounding, you know, what you can get out of this. But I thought it'd be fun to try and like duplicate that sort of gesture. And what I'm going to do is basically, let me show you kind of graphically here first, okay? Hold on, create a new image. Okay, create. Okay. What I'm going to do is I'm going to take a note. I'm going to schedule it, okay? And then I'm going to take a certain amount of time, okay? I'm going to schedule another note, okay? Say that time is like 1.0 seconds. What I'm going to do then is take half of that and schedule it then. Then I'm going to take half of that and schedule it then. I'm going to take half of that, schedule it then, okay? Some of you may recognize this as one of Zeno's famous paradoxes from Greece, the idea that you can shoot an arrow at somebody and it will never get there because it always has to go half the distance first, and you take half of that, you know, schedule a note. So basically, I want to create a sound that kind of goes dunk, 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 kind of like that. Then I'm going to reverse it and get it to come back, okay? How am I going to do that? Well, let's see. Do I want to type this? Yeah, I'll type it in for fun, okay? Let me save this now as something else, okay? Save as, okay? We'll call this Zeno1, okay? Right. Okay, and I'm going to get rid of all this nonsense, and I'm going to go back to, I think, strum for this because it's got a real nice sharp attack and you can hear it kind of happening really, really well. Okay, so let me go. I can never remember the parameters. So I'm going to go back here to my RTC mix page. There it is, strum 2. Grab my quick syntax. Okay, and I'm going to say start equals 0. Then I'm going to say, oops, next equals 1.0. You're going to see how I'm going to use that. I'm going to say for I equals 0, I is less than 10, I equals I plus 1. So I'm going to generate 10 of these notes, okay? And that's because I fooled around with it a little bit ahead of time and figured out that 10 is like not a bad number, okay? It's going to be start, okay? Our duration will be let's make the duration, yeah, let's say 0.5, okay? Our amplitude is going to be 20,000, okay? Our pitch will just make, now, here's where I'm going to introduce something else new. I want this to be, if I was playing it in 44.1K sampling rate, I want this to be middle C. You know, I can go through and figure out, well, middle C is 262.5 hertz or something weird like that. Or I can type 8.00. Okay? This is an old kind of Princeton, Columbia notation back when they were really into serial stuff and they were really into numbers for all their music they were doing, called octave point pitch class. Okay? Octave 8 is the middle C octave. Octave 9 is the octave above middle C. Octave 7, of course, is the octave below middle C. That's middle C. That's C sharp. That's D. That's D sharp or E flat. That's F. That's F and a little bit more, you know. So this is a way of specifying pitches according to our standard Western stuff, okay? So I'm going to say, hey, play middle C. Squish, again, I'm going to use 1. Decay time, I will use, oh, yeah, let's make this be a stereo thing now, okay? Because I want to introduce you to fun stereo stuff, okay? So I'm going to give it 2 channels, and I'll take this and make it come out of there, okay? All right, so decay time, we'll just make it also be the same as the duration 0.5. And then the pan, right now, I'm going to say 0.5, okay? The pan value is between 0 and 1 when you have a two-channel RTC mix. 0 will go to the left channel, 1 will go to the right, 0.5 will go to the middle. So we're going to be using that a bit more in the future, okay? Now, here's the Zeno part. I'll say start equals start plus next. And that's my loop, all right? So no, oh no, I have to do one more thing, okay? Then I'm going to see next equals next divided by 2, right? Because we're having it each time. So what's happening here is that the first time I'm adding 1 to start, which was 0, so it turns that into 1, but then it changes next to be 0.5. So when I loop around again, this is now 1, this is now 1.5, so that becomes 1.5. Then that becomes 0.25. See, so that's my Zeno part. Okay, this is where I'm adding half the amount every time. Now, fortunately, I have a limit and I know how many notes I can go, because again, if I was like, following Zeno, this would never reach the end point, if I wanted it to go to some particular point in time or something like that. But I'm just going to say, hey, do 10 notes, that's going to be enough. Let's hear what it sounds like, okay? And it's not going to be perfect, okay? So here we go. It's doing it, okay? However, it's doing it much too fast, okay? It turns out that having it is a little bit too quick for what I want to do. Yeah, they get all bunched up at the end. So there's a way of dealing with that. I'm going to change this to be times 0.5 instead of divide by 2, okay? I don't want to have it every time. I want to maybe do something like, say, 0.6. So I'm not decreasing the next time as much, okay? Now let's hear what that sounds like. Nope, still not so good, okay? So let's go clear to, say, 0.9. So each time it's only 9/10 as long as it was before. Okay, let's try that. Okay, that's okay, but now it's taking too long, okay? Let's try 0.8. That's pretty good, okay? Just for fun, let's see what 0.7 sounds like, okay? That's not too bad. I think I like 0.8 better, okay? We'll split the difference. We'll say 0.75, okay? Now, what I did there was another demonstration of what's fun about doing algorithmic composition. It's going in and messing with the parameters and seeing what you get. I could have sat there and tried to figure out mathematically, how much time I was going to have in those like notes towards the end of it, but it's a lot more fun to just go say, hey, that's not right. Let's try something else, because that's when you start really unlocking the power of this stuff to try things out, and see where it gets you. All right. Now, that's all well and good, but like I said, I wanted this wave. I wanted to go up, and then I wanted to come back down. How do we do that? Well, we take all this and we duplicate it. Only now, instead of multiplying it by 0.75, we will divide it by 0.75, because it'll be the reciprocal, which will then add to it as it gets farther out. All right. Now, here's what's fun. Notice that I didn't reset the value of start or anything like that. That's because these values have been set here. So start, by the time I reach this second loop, is going to already have the value for the very next note that should occur. Is that making sense to you guys? Okay. Because I've unrolled this loop, then when I get to here, start is now set to be like 2.57 or whatever it's going to be, okay? So then it picks up from there and then starts adding next, and next is already you know, down to like whatever it is, you know, 0.12 or something like that, you know, then it will start building next back out again because we're dividing it by that 0.75. Okay, so at this point now, when I play it, I'll call this Xeno 2. Okay, now I should get. Oh, cool. That's exactly what I wanted. Okay, it's so great. I'm going to listen to it again. Okay, so that has that nice kind of like wavy shape that I wanted. Okay, now obviously I'm a lazy composer, right? And I don't want to have to hit the bang. I want those waves to just kind of continue and continue and continue. Again, there's two ways that I could do that. Okay, one was to use the metro object, but I'm going to do something else. I'm going to have the script trigger itself. Okay, how do I do that? Well, by the time it unrolls both of these loops, start is now set to be when the next note should occur, because we're constantly adding to start. I'm going to use a special instrument called max bang, and I give it the value start. What this will do is generate a bang. And actually it's called max bang even in PD because I wrote the max object first, okay? It will generate a bang at that time start. Well, where does this bang appear? Well, it comes out right there. So what I can do is have this go around, hey, yeah, it's going around, it's going around, and going around, and re-trigger the script. So when it unrolls all this, then it'll say, all right, I'm going to schedule something else, and it's going to be a bang, and I'm going to schedule it at that time start, so it will re-trigger the whole script. And now it will run forever. Yeah. Eventually you have to turn it off. You could put a gate in there or something like that if you wanted to control it, but yeah, I didn't care. Okay, so we'll call this Xeno 3. All right, and we're going to leave that for a while. Okay, because now I want to leave deterministic sort of approaches, and we're going to now look at probabilistic approaches. Okay, and let me see what we got here. Yeah, here's one more. I think I'll type this in. Yeah, because I got some stuff I want to show you, and as I'm typing, I'll talk about it. Okay, but then we're going to start probably just loading them in so you don't have to see me painfully type everything by hand. Everybody doing okay? Any questions so far or anything like that? Okay, I can't see the chat. Oh, yes, Shaw. Dave Shaw?
Justin.
Okay, sorry. I see you as Shaw. So
Oh, yeah, sorry.
Okay, Justin, what's up? What's up?
Every time I try to add an RTC mix object to pure data, it just like crashes instantly.
Ah, interesting. Okay. Are you using it on Macintosh or on Windows?
Mac.
Okay.
But I think Artun is using it on Windows, so the same thing is happening.
Yeah,
there.
mine crashes when I bang the RTC mix object in pure data, and also the editor of the RTC mix doesn't start when I double click it, even outside the edit mode.
Okay. Tell you what, could you guys send me like some example scripts? Actually, could you send me your PD patch? Could you save the patch with the RTC mix stuff in it and send me an example script of what's crashing it?
I forgot where I did the whole setup, but I will.
Okay, don't worry about it. Yeah. Dang.
I'll try this as well. Maybe I can just take a look at it right now. Actually.
Okay, that's a good idea. Yeah. You're both using Windows 10, correct?
I'm using Mac.
Oh, you're using Macs. Yeah.
Yeah.
Okay. Yeah.
Mac. I'm Mac. I don't know what think High
Okay.
Sierra.
I suspect it's probably something having to do with the installation. That's something we're going to have to take a look at. I've had a number of other people who have used it successfully, so we will get to the bottom of it, you know. But I'm sorry about that. Okay. So yeah, owner, if you could take a look maybe and see if you can figure out what's going on. Then
Yeah,
we'll
I
kind
just
of.
realized I don't have PD on this computer right now, but I'm just installing it
Oh,
right now. I'll
yeah,
check it a second.
it'll take it. It's trivial to download and install. Okay. All right. Yeah, I'll talk with you guys more about that later. Okay. Any other problems by anybody? Any other questions or concerns? Okay. Cool. All right. So let's
Yeah,
enter.
Brad, I
Oh
had a
yeah.
question. I put it in the chat.
Okay. I can't see the chat. I don't know what the story is here. When I share my screen, my chat like goes away.
Well, basically, when I add the RTC mix node, it's oranged out, and in the console it says RTC mix tilde unable to load object bundle executable
Okay. You're using it on a Mac or on a Windows?
on a Mac.
Okay. Again, it's an installation problem there for sure. Okay, because it's not finding it. Yeah. Well, John, I think I'll set up a session with you, and yeah, Justin and Artin will probably do the same thing with you at some point too. Maybe tomorrow. Okay.
Okay.
What you might want to do is you took the whole RTC mix folder and dragged it over into your users share Mac 7
Yeah, exactly
library.
what the instructions said.
Okay. That's
And
really
I
good.
checked my version of OS, like Mac OS, and I'm on 10.14, so I'm not at Catalina, which
Okay.
is where you said there'd be issues. So I don't think it's that.
No. The issue is to say it can't load the library. It won't gray out the object. Okay. That suggests that it's not finding the object for some reason. Okay. Yeah. So we're gonna have to double check how the install went. You know. Yeah. Sorry about that.
No
Okay.
worries.
I hope to switch to Macs actually as soon as we receive the licenses, so it might not be a problem maybe once I switch to Macs.
Yeah, but I'd like to solve it, you know, because there's a
Sure.
fair number of people using Windows, so I'm going to use you as a test case too. Okay. Alrighty. Yeah, we'll get this happening. Okay. Is anybody else using the PD object on their machines by any chance? Okay, we'll figure it out. Alrighty, guys. Oh, I figured out how to get the chat object up. Okay. All right. The crashes. Okay. Okay. Yeah. Okay. Yeah. We'll yeah, check the chat stuff. Okay. Anyhow, let's go ahead and move forward. Next thing I want to do is let's clear this out. Okay. And let's go back in here. Let's see this chat. Can you guys see the chat window in my screen share? You guys see that? Isn't that bizarre? Zoom is just bizarre. Okay. All right. Okay, let's get rid of all this, okay? And here's what I'm going to do. Okay, I'm going to go ahead and just type this in. I'm going to say amp equals 10,000. Okay, amp env, okay. And that's going to be equal to make table. Line, okay, 1,000. Okay, 0, 0, 1, 1, 2, 0. That'll just be a fade up and a fade down because I like to do that. Okay, let's make the duration equal 3.4 for fun. Let's say start is going to be equal to 0. Okay, let me set up my for loop here. I equals 0. I is less than 20. I equals I plus 1. Okay, and then we're going to do a wave table. Okay, let's say wave table. Okay, and we already have some of the things. We have the start, we have the duration, we have the amp times amp end. Now, frequency. This is where it gets fun, okay? I can say frequency equals 500 or something like that, or I can add to it, or I can say frequency equals IRAND 200, let's say 300, 700. Okay. What's this going to do? IRAND stands for interval random, and it will choose a random number between 200 and 700. Okay, so this is basically just going to do a probabilistic sort of thing where it's just going to randomly choose something within that constraint. All right, and then we'll say we're going to use our pan thing, and we're going to say pan equals random. That's one of those optional parameters. Random is a random number generator too, but it always returns a random number between 0 and 1. Remember I told you that pan went between 0 and 1, 0 on the left, 1 on the right. So this is going to take every note and put it at some random location in our stereo spectrum, okay? And then the final thing that I'm going to do is add another parameter that was optional. I'm going to say waveform. Remember I said that the wavetable would default to a sine wave? Well, you can override that default by rewriting another of those tables using make table. And I'm going to make it a waveform table, and I'm going to make it be a triangle wave. So instead of a sine wave, it'll be a triangle wave, okay? And just for fun, let me make sure that I have enough. I'm going to say reset 44100 so I get nice smooth envelopes because I don't want to have any other messy envelope stuff, okay? And then just for fun, let's say start equals start plus 1. So we'll have kind of like a nice sort of relaxed scheduling of notes, okay? So this is going to make 20 notes. Each one's going to be randomly between 200 and 700. And there's going to be like 2 seconds of space between each one, okay? Let's hear what that sounds like. Okay, save. Okay, we'll call this wave1.maxpatch just for fun, okay? And now we start it up. So we can just kind of bliss out on random notes, okay? Now I'm going to show you something else that's fun to do. I've been triggering these with a single bang, but you can trigger things repeatedly. Oh my gosh, isn't that weird? Do you know who this is? That's Jesse Cox. I was putting his thing up on the CMC webpage, and I used that picture of him. I just noticed that up there. Sorry about that. Jesse, you're going in the garbage. All right. Anyhow, so you can do this, and then I can trigger more notes. Ooh, isn't that fun? So you can just like kind of nicely float away, you know? Or you can always do what I love to do is the opposite, you know, 0.01, 2000, okay, 5. Let's see what this sounds like. Oh, not what I expected. Why not? Because I'm adding 0.5 and I wanted to add 0.05. Actually, let's add 0.02. Oh, let's add 0.005. Yeah, let's hear that now. Fun with algorithmic composition, you guys. I mean, again, that's just going in and just saying, what happens if I do that? What if I make the parameters instead of 200 to 700? What if I make it 600 to 700? You know, I'll get something like this. Okay, then it begs the question, what if I modify this dynamically, you know, within my loop? And I'll leave that as an exercise that you all can try if you want, okay? All right, how are we doing on time? Pretty good? Are anybody getting totally burnt out yet? Okay, cool. I hope, again, it's not too boring or anything, but we'll keep it going. All right, Now, this one, I'm not going to type it in because, you know, you're getting tired of seeing me type stuff in. Okay, I'll save that as wave2 just for fun. Okay, I'm just going to open up one that I've already pre-made. This is going to introduce another RTC mix sort of capability. It's called an array. Okay, let's see, 150. Okay, all right. Look at this up here. Okay, basically, when I specify a variable, if I have curly braces like that, that tells RTCMix I'm going to specify an array of numbers or a table of numbers or something like that. So basically, I've set aside a set of numbers, middle C, D, E, F sharp, G, A sharp, and B flat, you know, B sharp, you know. What I'm going to do is just cycle through that array, okay, or just once, okay. Start's going to be equal to 0, and I'm going to go for the length of the array. Send notes, okay. Len is a function. It takes an array as its argument, and it returns how many elements are in that array. So I could go in and add more and add less, and I don't have to change my for loop, okay. What it's going to do is it's going to assign pitch value is going to be the array with the I inside these square brackets. So that's going to go 0, 1, 2, 3, 4. In RTC mix and in a lot of computer languages, you count from 0. So element number 0 here would be that one. Element number 1, when it loops around, would be that one. Element number 2 would be that one. So that's how we access these values in this array. Now, the thing that I'm going to use is I'm going to use this thing called M-modal bar. And again, I got that from the documentation. I'm not going to bring it up. Okay, but this is what it told me. It's a physical model of basically a marimba. Okay, it's a struct sort of metal type thing. All right, and it wants its frequency specification in cycles per second, not in this octave point pitch class. However, I wanted to have a nice diatonic-y type thing happening. So I can convert that pitch value, 8.00, to its frequency by using this function in RTCMix called CPS-PCH. It converts octave point pitch class to cycles per second. And we have a whole bunch of those different kinds of converters. They're all in the documentation. I will show you that, I think. Okay, if you go back here to score file commands, and you go down here to pitch specification conversion, these are all the different kinds of things. You can use MIDI values, you can use different kinds of whatchamacallits, all kinds of stuff like that. Because it turns out there's a lot of different ways of specifying pitch in the world. So we decided to try and, you know, encompass as many as we could. All right. So here we come, modal bar. We give it the start value. We give it a duration, an amplitude. We give it the frequency. We're just going to go through that array one at a time for the length of the array. And then the rest of these parameters I just copied from the documentation. Okay. And we're going to add 0.2 of a second. So every 0.2 of a second, we should hear the next note in the array. And it's going to sound like this. Yep. Yep. Okay. So that's fun. But what's even more fun is to randomly access that array. Okay. Here we go. How did I do that? Well, in this case, I have a smaller array, okay? I'm only using 4 notes, okay? And for those that are into, like, you know, serial theory, that is in fact an all interval tetrachord. Ah! Yeah. Just, yeah, never mind. Okay. So what I'm going to do is, instead of just playing 4 notes, I'm going to make start go until 7 seconds in. Okay. The duration is 0.1, and I'm going to go to 7 times that duration. Okay. So I'm going to generate 7 notes, basically. Okay. And I'm going to add the duration to start right here in my loop. Okay. Now, here's the fun part. we have another function called pickrand, where you give it the array and it will pick one of the values from it randomly. Then we just do the rest like we did before, okay? Notice that I'm not saying start equals something down here. It's because I've embedded it now in my for loop. And again, I'm not going to really explain this now. Take a look at it, you know, and kind of figure out what's going on. Initial condition, ending condition should give me 7 notes, and I add duration each time. So now, when I play this, I should get okay. So I'm randomly choosing, you know, from those 4 things. Now, why did I choose array with just 4 notes? Because I want to do something even more, okay? What I'm going to do, you can see why I stopped typing things in, because this would be painful after a while, all right? Oh, look, 2 different arrays. There's my original one, which I'm now calling notes 1, not just notes. Then I have another one here, which is a nice, you know, non-all interval tetrachord of just, you know, a nice kind of diatonic-y, G modally, G, B flat, C, D, E flat. You know, it'd be kind of a nice sort of sounding chord. And I have this thing called chooser, okay? And chooser, I'm going to be setting to random. Remember, random returns a value between 0 and 1. Now, when I go down into this loop, if it's less than 0.5, I use the first array. Otherwise, else, I use the second array. Okay? This is a common thing. Looping is very important. Decision making is very important. This is the way you make decisions in lots of computer languages and in RTC mix. You say, here's the decision condition, and if that's true, you do the things in those curly braces. Else, you do those things. And you can actually have a whole set of ifs. You can say if chooser is less than 0.2, if chooser is less than 0.3, if chooser is less than 0.4. You can construct the logic however complicated you want. You can have nested ifs. You know, in fact, when we talk in 2 weeks about Markov chains, that's basically all a Markov chain is nested set of if statements. Okay, so I'm going to choose my pitch from either this array or this array, depending on the random choice of that chooser. Then I'll calculate my frequency and I'll play my notes. So now, every time I hit the bang, yeah, notice it kept alternating. I'm going, oh, that's not what I wanted to show. It's random, you know, so I don't know exactly how it's going to unfold. And it turns out that it actually did like a whole series of back and forth. And finally, at the end, you heard it kind of stuck with the first note array for a while, okay? By the way, I should mention something about these random numbers too, okay? These are pseudo-random numbers, okay? Let me play this again. Notice it was different that time, all right? That's because if I don't specify something, a pseudo-random number means, you know, computers don't really know how to do random numbers. You know, they don't look at the quantum state of something and figure out, oh, what is this? You know, some computers do, but they're really expensive. What they do is they have these mathematical techniques for generating what looks like random sequences, all right? They are all controlled by a starting state. If I don't specify that starting state, it uses the system clock to dictate the starting state. So for all intents and purposes, it's random. However, you can actually specify the starting state by saying seed and giving it a number. Now, start it again. Ooh, it didn't work. Maybe that's supposed to be 0.7. Try this. Oh, no, it's not working. I got to check something here. But that was supposed to set it up so that basically it would always do the same random sequence, okay? Apparently it's not working, so I have to find out what happened. Something that somebody did probably. Okay, but just bear in mind, you know, that sometimes you're going to get the same thing. You can control it theoretically with that seed value. I'll look up and see what's going wrong, and I'll report back next week. So because that's actually kind of important to kind of know about. Okay, all right. Now, I'm going to show you one more of these array choosing things. I think this is it. Yeah. And basically, this is the same thing that we did before with the probabilistic wave thing, is that same script, only this time we have a max bang at the end, so it will continue over and over and over again. Yeah, fun stuff. All right, now I did one more. Bring that up. And this one is interesting. And you'll see I've added some stuff out here. I'm going to talk about that in a second, okay? What this is going to do is it has a single array that's pretty long, okay? What I want my algorithm to do is walk up this array and randomly choose from three values. And it's gradually going to walk up and always move the window of randomness as it goes up. So that basically it's going to use this value called base, and it's always going to add 1 to it after it generates its 7 notes, okay? And if it gets greater than the length of the array minus 3, or when it gets to there, it will go back and start over again. Now, why did I have to do that? Because if I let base go here and it tried to choose from the next 3 notes, there's no more notes. And it'll say, there's no more notes. And it will probably crash. Actually, I think it repeats the last note over and over and over again. But basically, that's called exceeding the bounds of the array. And that's a bad thing to do generally in programming. So you have to be aware that you're not going to go past that. And that's what that's about. If it gets greater than that, then it resets it to 0. Okay, so what we should hear in this case, oh, why is this thing out here? Well, that's because I initially have to set base to something, okay? I'm always adding 1 to it. If I set base in here, base equals 0, basically every time I triggered the script, it would reset that to 0, right? So what I'm doing is I'm taking this initialization out here. I'm going to hit that first. Now it's set to 0. Now it can do its thing. Okay, so you can hear it's doing the thing over and over and over and over again. Okay, now I did one more variation of that. Okay, and that's this, where instead of having the algorithm walk me up and down, I'm using this slider to generate the base value. Now, notice that the slider is going from 0 to 1. All right, keep that in mind. And how do I get that value into RTCMix itself? Well, I use this message where I say var1, or the first variable, is going to be set to this $1, which comes in here. Now in here, temporarily, base is set to this $1, and it's between 0 and 1. I scale it to 0 to whatever that is, like 10, I think, by multiplying 0 to 1 by that. That gives me my full range as I move the slider from 0 to 1. Now, the thing I have to do there when I assign base, though, is that this is going to be some value. Notice that these are like non-integer values, like 0.523, okay? So if I multiply 0.523 times that length, it'll be something like 6.935 or something like that. Well, I want to have just 6 or 7 or 8 or 9. I don't want to have the decimal part, because the decimal part will actually cause it to do an interpolation between those. I'm not going to go into that right now. In order to get rid of that decimal part, I have to truncate that value. So now base is going to be something between 0 and that value there, whatever it is. Oh, there's a cat on the screen in one of you. Okay. All right. I know I'm going a little bit fast with this. Again, I'm going to put all the code online. Take a look at it, and once we get you guys happily running with RTC Mix on all your computers, just come back, and if you got questions, we can answer them. Okay. We're almost done with the class today. Okay. I know it's getting a little bit long now, but the next part is really fun. Okay. So here's what we do, okay? Start this out down here and start the thing. Now as I move this slider, I can control where it is. Okay? And that's going to be one of those control features that we can use maybe in some kind of weird network situation or something like that, okay? So again, this is why I'm having people use Max MSP. By the way, you guys, if you want to go ahead and start using some RTC Mix stuff without this external control thing, you can download the RTC Mix shell. And that is a standalone program that should run fine on both Windows and Macintosh. John Gibson's tested it out quite a bit. So you could go ahead and at least get some of this stuff happening for you without the fancy kind of max bangs or anything like that. All right. Again, I apologize for that. We'll make it good. Okay. So that's that. Now, we're going to do one more thing, okay? Let me take a look here. Yeah. This, we're going to go back to that Xeno stuff, okay, that I did. And this is kind of like a model, okay? One of the things, if you watch waves, what's really fun about them is the way they collide. When you have several waves together, how they combine and create almost like a randomness, even though each wave is pretty much a simple harmonic oscillator, I thought, man, I would like to capture that randomness as part of my algorithmic practice. And we're going to take those earlier things we did with, that we called Xeno, and we're going to use them in a different way, okay? Let's bring this up. Okay. Now this is the basic thing. Only notice that I have no wavetables here. I have this thing called print. What I want to do is show you how you get data out of these RTC Mix scripts that you can use. All right. What print does is it will take the value of what you're doing and it will print it into this max window, which is kind of cluttered with the notifications that RTC Mix started, okay? In fact, if I start this up, you'll see it generated an RTC Mix started thing. Now, when I trigger this script, which is nothing but these print statements in place of any wavetable, watch what gets filled in the Max console. Boom. Those are the actual values that were calculated. And you notice it starts at 1, okay? And it goes up. Whoa, it's still going. Yeah, I guess it went a number of times. Oh, that's because the max bang is banging it around. I forgot. Yeah, it's repeating over and over again, but it's really kind of fun because you can almost see that waveform. There's a 1, then it goes 0.7, 0.49, all the way up, and then it gets really short there, and then it kind of like goes back down all the way back to 1, then 0.7. So that's actually the values, all right? Now, that's all well and good, but it doesn't do us a whole lot of useful sort of stuff if it's just in this max window. How do we actually get it in the context of a max patch that we can use? Well, here's how you do it. We use an RTC mix instrument called max message. And max message is scheduled. We give it a starting time, initially at 0, and then we add our next to it each time, and then we give it the value that we want it to put out. So that means every time it sees this and it generates something, it'll put out that value at that time. And then I do a max bang so I can keep it going over and over again. Now, that means that we have to do double duty with the things coming out of that outlet in MaxMSP or in PD when we get that running. Basically, if it's a floating point number, we send it out here. If it's a bang, we send it up to the bang. So that way we can get our bangs continuing, but we can actually see the values as they come out. And watch, when I trigger it, there goes 0.7, 0.49, fast, slow, 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 back to 1. And there was the bang. Fast, slow, 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 back to 1. Okay? This is the mechanism we can use to create like a wave, all right? What do I mean by that? Well, I'm gonna take this. What the heck? Okay, that was a bogus one. This is the one I want. Yeah, what's going on here? All right. Well, up here, this is what I just showed you. Only we're going to use that mechanism of getting values in to another RTC mix process. Same way I use that slider, we're going to say, here comes these values. We're going to be assigning them to that $1. And this RTC mix basically generates a single note. It takes that frequency value and runs it through and basically feeds it into a wavetable. And now we'll start this out, and now we'll listen to it. Okay. Now that's because I'm using a very short duration for the wavetable, okay? And I'm also doing something really weird up here, okay? I'm subtracting that. That's because I wanted it to go up and down in pitch rather than down and up in pitch, because as the values get smaller, they would go, basically I'm multiplying by 1,000, they would go down towards 0. And as they got larger, they'd go up towards 1,000. And I'm just converting that directly to frequency. So by subtracting them from 1, it inverts that relationship. Again, I think I'm kind of losing it here a little bit, and I'm not doing a very good job of explaining this. Yeah, I want you to take a look at the code. Let me run ahead, because I know when I'm starting to lose it, that means that the rest of the lecture is going to go downhill quickly, and this is the last thing I want to get covered. I also noticed that I forgot to plug my computer in, and I'm almost out of power. Okay, let's take a look at, I think, this one. Yeah, let's try this. Oh, that's I just had the Metro generating the stuff. That's not that important. Okay, let's take a look at this one. Yeah, this is where it gets fun. Okay, because instead of just one of these Zeno processes, I have 2 of them. Okay, and in this one, I'm adding 0.7 each time. And in this one, I'm also adding 0.7. That doesn't make any sense. Well, let's hear what they sound like, you know. Okay. Yeah, that you can kind of hear the waves beginning to interfere with each other. But this is the one that basically does the whole 9 yards, okay? I have 3 different wavelets. This is going at 0.7. This is going at 0.8. That's what I wanted. So it's a slightly different sort of frequency of the wave going, and that's going at 0.9. All 3 of those are feeding their numbers into this RTC mix process, which is going to add them all together, and we should get the result of 3 waves that are converging on a single point. And we should then be able to hear that point. So let me start these guys up. Okay, and I'll start this out. So you can hear it's actually then doing kind of like a semi-random kind of tracking of this, but it has sort of a character to it where it's, you know, kind of smoothly going along. That's exactly the character of those waves converging that I wanted to get. Now the sonification is pretty stupid. It's just a sine wave. But imagine this with a kind of more interesting instrument of some kind. You know, all of a sudden it sort of starts to come alive a little bit, and you know, you can start doing some pretty interesting work with it. Anyhow, and again, that's just an example of how you kind of like take something from real life and model it. Okay. All right. I'm going to end with one final thing. Okay. And that is that you can use sort of algorithmic techniques to sculpt sound too. All right. Here. What am I doing? I'm generating 4 wavetable instruments. The jur is quite long, 21 seconds, and my make table, it kind of fades up, hangs out for a while, and then fades back down. And it's also using a sawtooth waveform with 7 harmonics. That's what saw 7 means, if you look in the documentation. So this is going to be a fairly low, it's 2 octaves below middle C, and I have this thing called deviation. Notice that my pitch, what I'm doing is I'm adding, every time I schedule a note, a random value between 0 and that deviation, okay? So basically, let me make that deviation a little bit less, okay? Basically, what this will do is generate 4 notes. Pan is going to like move them across the spectrum with that sawtooth waveform that are all going to be slightly detuned from each other. And instead of like a dopey wavetable sound, you get this. A nice droney wavetable sound. Or you can get it to be even weirder. Ooh. The B52s are coming. So by changing that amount of deviation that you have, let's say 0.35, you can get different effects out of this. Yeah, let's make it be 0.55. Let's see what that sounds like. Yeah, so essentially you can use these algorithmic techniques to kind of sculpt sound too. And that's actually a very powerful use of them by, you know, making the constraints very focused. You know, you can get these very interesting kind of textures that happen. They're the result of combining several different sort of sound sources, several different processes. Okay. Like I said, I think I'm kind of at the end of my rope here, and I think you guys probably are too. So yeah, let me see my chat. Anybody?
There was John and Mahir had a problem like using the RTC mix object within Max. I think they like I thought it was like a 32-bit issue, like because we could sometimes Max automatically defaults to 32 bits.
Yeah.
Mahir solved it. I think John also solved it by just unchecking that box in the get info menu item when you right click on
that makes sense.
icon.
I didn't exactly solve it. I would say that I kind of solved it. He's right. It's running in 32-bit.
Okay.
But when I went into the get info, it wasn't checked. It was unchecked and still running in 32-bit. But I just booted up Max 8 instead of Max 7, and that was running in 64-bit. So I drug the folder over to Max 8's library, and it works now in Max 8.
Okay. Hey, John, if you want did you get the original? Yeah, there's a 32-bit version on the rtcmix.org website if you'd prefer to use your Max 7 32-bit.
Okay. I don't know
Okay.
why it's running that way, but it appears to be stuck that way. So I don't know.
Okay. Alrighty. Yeah. We can probably talk about this. Okay. That's good to know. Okay. We solved that. So RTune, then we have a PD problem in OS X and a PD problem in Windows. Okay. So we'll take a.
I couldn't reproduce the PD problem on High Sierra that I'm using right now. I can try it also in Windows, but I mean, I just use a very simple score file, like just a wavetable object with like a 440 like a kind of sine tone.
Yeah.
It didn't crash when I banged the object or tried to open the editor.
Right. Justin, for you in RTune, it crashed no matter what you tried, right? Like, you couldn't even do like a very simple score. Yeah. Okay. Yeah, there has to be something in the setup that I just don't know. Again, I'm kind of a Windows neophyte, so we'll take a look. And
It could be something related to maybe if Zoom is using your like a certain audio device, maybe when PD also tries to hog that, there may be a problem with that, because I use different audio devices. Like I'm hearing this is like a different audio device, and I use the internal speakers for PD. Maybe that's the case. I don't know.
Yeah, maybe try it after we exit the class. Try it, and just very simple sort of thing. And yeah, hopefully. Yeah, the editor thing in PD, that's a tricky one on Windows. Yeah, you notice the documentation is a little bit weird for that too. You might try bringing up the help patch and running some of that. That's what I use to test my PD installations and see if any of the help patch stuff, runs okay. All right. Yeah, we'll get to the comment of it. Okay. Oh, I do see from Leaf and Adam, is there a way to comment out the code? Yes. Like I said, we've seen that you can do stuff like this to comment out single lines, but you can also do this. Okay. This is kind of standard for a lot of programming languages. Everything between that /* and // that's now commented out, and it will not be seen by the parser. Okay. So you can do like major blocks of code coming out, and you don't have to go through and do this, for example. You see what I'm doing? Yeah. So yeah, that's a very helpful thing for when you're working up something and doing some stuff. And there's a lot of things that I'm not showing you. Doug Scott will show you some others. You can use include files. You can create functions. So it's not it's not all just kind of straight ahead like this. And we'll be getting to some of those things later on. But yeah, I hope this kind of made sense. Like I said, my intention is not to assume that you guys have like a huge amount of programming experience, because most of you don't. It's more I wanted to show you just kind of a way of thinking, a way of approaching this, and just kind of taking very simple things, looping, if decision constructs, and then just kind of gradually thinking through the logic and building up something a bit more complicated. So yeah. So like I said, next time, maybe it's good we take a little break. Doug Scott will talk about his stuff, and then the following week I'll be showing you some more interesting kinds of algorithmic stuff. Yeah, chaos.
Could I jump in for a sec and just like offer a tip to the people who don't know how to program stuff?
Sure.
So like if I had looked at this a week ago, like when you showed it to us a week ago, I said, oh my God, I can't do this. But then I went on Code Academy, and they had a bunch of free stuff, and they had one that was just called like learn the fundamentals of how to code. And it didn't teach you any specific language. It kind of just taught you the logic of how writing script worked. And that was immensely helpful for me to understand what you were doing today. So I would recommend that to other people that felt a little overwhelmed with this.
Right. John, could you send me that link and I'll put it on the webpage for the class?
Yeah, I will. Okay. And the course was probably like an hour.
Oh, cool. Wow.
It helped a lot.
Yeah, I know there's a lot of resources out there. A lot of them, they start out pretty dense, by saying, here's how you declare your variable types, and things like that, which we don't even bother with,
No.
But that sounds really useful. That sounds actually really good.
Yeah, it was just basically the logic of like what a variable is, what a function is, what script kind of looks like, so you could look at code and kind of figure out what was going on. And like I said, it was probably an hour or two, and it was immensely helpful to me. So
Very cool.
I'll
No,
send
no,
you.
I'd really appreciate that. Yeah, don't. Yeah, you can send it in the chat and I can see it, but just send me an email too. Okay.
Will do.
Right. In the meantime, yeah, we'll get to the bottom of the PD problems that we're having, and yeah. Okay. All right, gang. Well, I'm going to call it quits for now. Like I said, it'll take me probably a day or two to get all of what I showed you put up on the webpage. Now, I'm going to create 2 different archives. One will be the max patches that I did, but the other one will be just the RTC mix scripts. So if you are using RTC mix shell, or we'll get PD running for you guys. If you're using PD, you can import those scripts as files and use them that way. Okay, the thing you won't be able to do is that kind of recirculating max bang and stuff like that. Okay, I see another message. Oh, thanks, John. I got it. Great, cool. Okay. Yeah. Any other questions or comments or anything? Yeah. Owner and Justin and Artun, if you guys could maybe hang on for just a few minutes. When people leave, we can talk a little bit more about what's going on with your computers. Okay. If you've got to go somewhere, we can do this another time too. Okay. But yeah, for now, I'll say goodbye. And yeah, send me an email if you got questions or comments. See you next week. Hey, Ben.
Brad, I used to work on Windows at Microsoft. Is it okay if I stick around a little?
Oh, that'd be really helpful, Doran. Yeah. Because like I said, I'm a Windows neophyte. That's really, really nice of you. Okay. Ben, I can't hear you. You're muted.
Hey, Brad, that was awesome.
Well, thank you, Ben. I'm glad you unmuted. I feel better. Yeah, it got a little random towards the end, I think. So, oh well.
Wasn't that the intention?
Right, that's true. Yeah, random. Okay. Anyhow, yeah.
I'll send you an email. I have a bunch of ideas.
Oh, cool.
Yeah.
Very cool. Okay, yeah, we're getting there. Your course in the spring should be much easier to run.
Yeah, but I'm going to sit in this and
Okay.
make
Alrighty.
connections. Okay.
Okay. So, Justin, let's start with you. I'm going to share my screen again. Okay. And I want to show you the process that I use to install RTC Mix tilde. Okay. For PD. All right. So here we go. All right, let me get rid of Max. Okay, let me go to my home directory. All right, so here's what I do. Okay, I'm gonna, wait a minute. Okay, let me go to, you're seeing my screen, right?
Mm-hmm.
Courses. Here we go. Okay, so we go to course syllabus. Let's go to week 1 where I have the link. And let's go here and we're going to get the RTC Mix tilde for PD. Okay. So we're going to get this. It's going to download it. All right, now I'm going to take that out of my downloads folder. See, Zoom, you guys don't see this, but the Zoom windows are getting in my way. Okay, here we go. Okay, we'll bring it over here to my desktop. All right, now I'm going to unpack it. Okay, and it says RTC Mix tilde for PD. So I go inside that folder. There's my RTC Mix tilde right there. Okay, so what I'm going to do is go up here to Documents, and I go to PD. I go to Externals, and see, I've already done this once. Okay, But basically, you simply drag that folder there, right?
Yeah.
Okay.
I already installed. I'm not getting an error message about RTC mix. Like if I make an RTC mix object, it doesn't give me an error in the console. It just like crashes when I try to do anything with it.
Okay, cool. That's fine. I just want to make sure that we're kind of like starting on the same page. All right, now I'm going to start up PD. Okay. Here's a question. I was using a slightly older version of PD. Okay, I'm using, oh, Miller, 0.0.0. No, I'm not using 0.0.0. I think I'm using not the 0.5-2, but the 0.5, but I don't think that should make a difference. Okay, I'll check that out. Okay. Okay, but basically, then I start a new PD window. Okay, and I create an RTC mix tilde object. Now, at that point, it crashed for you?
It's kind of circumstantial, but no, it doesn't crash yet.
Okay, all right, now, here's what we're gonna do. Okay, I'm going to, okay, close this. I'm gonna control click and hit help. Okay, did you get that?
Yeah, I
Okay.
did that before.
All right, now I'm going to turn on the DSP. Okay, and you should see these guys. Okay, now I'm going to play the current score file. Now, you probably can't hear that because I forgot to turn on my computer sound. But can you play?
What's like just by what's the like what button just?
Oh, it's yeah. Oh, yeah. Maybe that's what part of the problem is. Okay, when I turn on the DSP, okay, I hit this button here that says play current score file.
Oh, okay. So I just had to use the bang from the help instead of the. I was trying to put a bang in on pure data.
Okay.
That should still work. I mean, it shouldn't make any difference.
Yeah, let's do that. Okay, let's take this. Okay, and I'm going to put in a bang. What is the bang? Shoot, not that one. I forgot my pure data. Is it Command B? No.
Shift Command B.
Shift Command B. Yeah, Shift Command B. Okay, there's my bang. Okay, now I'm going to connect it to my RTC mix tilde. Okay, and now I'm going to create a DAC tilde. Is that what Miller calls it?
Yeah. Yeah.
Okay, and I'm going to grab my output from there, and I'm going to take my output from there. Okay, now I'm going to close this with Command E. So now my patch is locked. I'm going to click on this RTC mix tilde. That should bring up this window. I'm going to type waveform, wavetable, excuse me. Start of 0, duration of 2.1, amplitude of 20,000, and a pitch of 8.00, middle C. That's all we're going to do, okay? I'm going to close that. It'll say, document modified, save changes, yes. And now I turn on the DSP, I hit the bang, and I hear a sound. Okay, that should have been. You know, hey, Justin, you know what occurs to me? I didn't do a very good job of showing you guys how to actually use these tools. I think at the beginning of class next time, I'm going to take a moment and go through what I just showed you. Okay, but it sounds to me like it's probably working. It's more that you've got to kind of, you know, figure out how to make it work.
I think it might just be like pure data being really slow, because like when I brought up the help thing, it like the entire thing just like it's kind of frozen now. Like I can't do anything.
That may be what Ona was talking about. That's might be because of the Zoom audio stuff that's happening too. You know, yeah, I'm hoping that's what it is. Okay. Yeah. Yeah, fool around with it a bit. But that process of like creating this, clicking on it when the patches thing, that's the thing that you then go in and you type the scripts in, closing that off, turning on the DSP, hitting the button. That's the
I
basic
might
workflow.
try to maybe get an earlier version of Pure Data too to see if that
Right.
might help.
Actually,
I tried it on like the latest vanilla version that I just downloaded it. It works. I mean, again, I'm
Okay.
using like High Sierra, macOS High Sierra right now.
That's
It could
I
be
think
different
that's
on
what I have
Mojave
too.
yeah, I'm using High Sierra too. I didn't upgrade to Mojave yet. Yeah, that's as far as I'm going to go. I'm not going to go to Catalina.
or
Okay.
Big Sur is coming now.
Right. I know. Okay. So that, yeah, I'd say fool around with this, you know, and see where it gets you. Drop me some emails if you're having like serious issues, and we can, you know, maybe schedule another time where we can try these things out. Okay. All righty.
Okay.
Okay, good. One thing kind of solved. Okay, now Artun. Yours is
I will probably try to see if I can make it work. So
okay. Okay,
I,
no problem. All right, Justin,
thank
no
you.
problem. All righty, cool. Artun, one of the problems I have right now with you is, hey, did everybody go? Oh no, there. Okay.
No,
Is that I don't have my Windows machine set up with Zoom yet, so I can't show you what to do.
I think I did the installation correctly, the file where I moved. I mean, it was according to the directions. I think it's okay. And PD does recognize the RTC mix object.
Okay. That means you
But
did do
then,
the installation properly, okay?
yeah, I think so. But then
Okay.
it crashes. And also when I double click the object, it doesn't open up the editor for
Yeah.
me.
Okay. Now the editor is a little tricky. Did you download that Notepad++?
I think so. I mean, now I did it last week, but I did everything that the instructions wrote, but I
Yeah.
don't remember.
Okay. That's the trickiest. That's the tricky part about the editor is it has to, you either have to set it up to point to an editor that you have, or use the default is set up to go to that Notepad++, and I would need to see. I was assuming that it would be installed in a default location on your disk, and maybe that's not a valid assumption. That's what we'll need to check. I'm probably going to have to schedule a time with you where I can use my Windows machine. And
I can also take a look at. I mean, I have like I have Windows on my computer. And I
okay,
have dual
that'd be
boot.
great. Yeah, that'd be great, Owner. If you
I'll
could take
check
a
that as
look
well.
and kind of report back to us about that.
Yep.
Okay. Yeah. Now, describe to me again what happens, what causes the crashes.
I can share screen very quickly if
That'd
I
be
can do
great.
that.
That'd be great.
Let me very quickly
Oh, let me
open up
stop my
Pure
share.
Data.
Hold on. Okay.
So I have Pure Data open now. I will try to share screen.
Okay.
Okay, you see Pure Data now?
Yes.
Okay, I say File, New,
Mhm.
and I don't know if you see that one as well.
Actually, I don't.
I'll try to switch to that one.
Yeah. Hey, you know what? I got to turn my recording off too. Sorry about that. A little bit long at the